Hi everyone, and welcome to another training video from Split. Today we're going to talk about the implementation of Java SDK in slow networks and what are the issues there and how we resolve them. First, we'll talk about the flow for the JavaScript SDK inside the browser. So first we initialize the factory object or the client object. And once we initialize the factory, the SDK will actually start running thread to fetch the Split data from the Split cloud. So this will be dependent on the API key used and which environment the API key belongs to. And that's where all the information is going to be downloaded from all the splits that are added to that environment. Now, during that time, if the code, JavaScript code called getTreatment while the factory is still fetching the Split data, then we're going to get control treatment. So this is a more likely scenario in a slow network, obviously, because it takes a lot more time for the SDK to get ready and download all the information. Now, we do have a ready timeout parameter, and that parameter is set by default to 1.5 seconds. If the SDK is not ready within that time specified by the timeout parameter, then it will fire, the SDK will fire a ready timeout event. Now, the event doesn't do anything else other than getting fired, and it's up to your code to decide if you want to continue or you want to still wait for the SDK to be ready. Because in the meantime, the SDK will still continue to fetch the data and download the data until it has all the data it needs. And then it will fire SDK is ready event. Now, once the SDK is ready, if you do call getTreatment function, it will return the correct treatment since it does have all the information it needs. So we mentioned the SDK events, and here is a more explanation about how the SDK events fires. So once the factory is initialized, a thread will always check if the all content is downloaded. Now, if it's not, then it will, keep checking until all the content is downloaded, and once it confirms, then it fires SDK ready event. Another thread will always check if the ready timeout parameter has been reached. And if it's not, then it will keep checking. And if it did reach and the SDK is not ready yet, then it's gonna fire SDK ready timeout. So what happened in a slow network, like for example 3G network? The SDK timeout event might fire too fast if the startup ready timeout is too slow. For example, 4 seconds. So in a lot of implementation, people create promise, and the promise always checks if SDK ready event fires, then you accept the promise, and then you do the call treatment. And if the SDK ready timeout event fires, then you reject the promise, and in this case, you're not going to do the get call treatment. And you can see the issue here. If the ready timeout value was too low, like 1 second or 2 seconds, and in a slow network, which might take more than 2 seconds, it might take 3 seconds or 4 seconds, then the SDK ready timeout will fire before the SDK ready, and thus the promise will be rejected, and your code will not call the getTreatment. Another issue is when you do getTreatment call, not based on the events that the SDK is firing, but based on a different event within the browser. For example, you might call the getTreatment after the onDOM loaded event fires, since you want to make sure all the DOM objects are loaded, then you can do the getTreatment, so you can enable or disable, whatever DOM object. Now, if the onDOM load event fires, but the SDK is still not ready because we're on a slow network, then the getTreatment call is actually being executed before the SDK ready event is fired, and you're going to get a control. And this is a very common scenario that we see for a lot of customers who do not use the SDK ready events to check if the SDK is ready before calling the getTreatment. So how do we solve this issue with the slow network? So first, we need to simulate a slow network. The best way to do that is to use a browser developer tool, and here we're using Chrome. We enable the logging for the JavaScript SDK in the console so we can see what is it doing after the factory object is initialized. Now, when we run our page, we are checking for these times. So we look at the fetching split, how long it took, and we look at fetching segments, how long it took. And we take, of course, the higher value. So for our example here, the higher value is 2.5 seconds. Now, once we record that highest time it takes the SDK to be ready in a slow network, we can specify here that time in the ready timeout. And here in this example, we set up 4. So this means the SDK timeout event will fire after 4 seconds if the SDK is not ready. Another very useful option is to use a local storage type for the storage. Now, this means the SDK will store all the cache it gets from the split cloud into the local storage area of the browser, which means the first time the SDK runs, it will take some time to store the data or the cache from the split cloud, but afterwards, when the user opens the page again, it will use the current cache stored in the local storage. The only drawback for this is it's going to get stored as text only. It does not encrypt it. Another solution is to use the on method to run the getTreatment call. And this is what we recommend for everyone to use, so that it always wait until the SDK ready event fires, then it's going to call the getTreatment, and this way you know that you're going to have a correct treatment calculated rather than the control. You can also use a promise here, as we mentioned before, with the SDK events. So you actually create the promise and you resolve it when the SDK ready is fired, and you reject it if the SDK ready timeout fires. And it's important to make sure that the ready timeout is flexible enough so that you do not reject the promise while the SDK is still getting ready or close to being ready. Thanks for watching. Please head to the Split Help Center for information on our documentation and knowledge base articles.